Now the first thing I'm actually going to start working with is our actual little player paddle down here. And well, there's really not a whole lot we actually have to do now. I think setting up is probably most of the work. But let's go ahead and actually create a script for our player paddle down here. And let's set up the input so that when the player presses a certain key, we can move it left and right. So I'm going to come over here, and the first thing I want to do is actually create a folder for my scripts. And I'm just going to call this folder scripts. And inside of the folder, I'm going to go ahead and create a C# script. All the scripts in this tutorial will be C#. And I'm going to call this script player. I'm not 100% sure if this is a reserved class name. I'm just going to actually open up the script in MonoDevelop. Save it off. I'm going to come back in, just see if it gives me any warning about the name being not able to be used, and it doesn't, so I'm just going to go ahead and use it until I find out otherwise. And I'm going to throw some quick comments up here. I guess I'll just tell you what they are before I type them, just to save a bit of time here. And basically what I want this script to do up here, if you've followed along with our hack and slash tutorial, you know I usually put the date, or sorry, the name of the script, then the date, the person that created it, and then its purpose. So the script has a few things I want to do. Most notably, well, just get the player input and move the character accordingly. There's a few other things actually I want to do in this script. So I'm going to say move. I'm going to call it a paddle because that's kind of what it really reminds me of. There's a couple other little things I want to have this script do when it starts up. I want to make sure that it's always on the 0 for our z-axis. So if we come back in, we'll take a look at the player here. We notice that the position is on Z. And if we come take a look here and we switch over to looking at the side view here, or along the x-axis, we'll notice that everything is lined up along the Z. And what we're going to do actually is have the ball bounce around in here, and we're going to want to make sure that it doesn't move away from 0 on the Z, or it's going to not be able to hit these walls, and it's going to bounce off into infinity. But basically that's what I want to set up. So make some quick notes here. I make sure the paddle is always at 0 on the z-axis. We're going to want to set up some boundaries. So when we're playing our game, if we go over to the scene view, the paddle cannot move any further than this side, and likewise on this side. So for instance, this wall was, I think, 7.2 or something like that. Let's take a look. Negative 7.6, and we're going to want to make sure our paddle doesn't actually, go past that wall out into basically infinity, and likewise. And there's a couple ways we can do this. One, we can enable some sort of collision so we just can't move past it. I'm actually just going to hard code some values in, or at least expose some values that we can use to basically just stop the character from moving past there. So let's go ahead and make a quick note of that. Create side boundaries. The player cannot move by. Let me see. So we can move. We have boundaries. It's always on the Z. And another thing is we don't want our character to move up and down, so we're going to want to lock the Y as well. So I'm going to lock that in here. Make sure the paddle is always at the same position on the y-axis. Now this might change depending on your assets that you're using and the aspect ratio you're using, so I don't want to bind it to 0. In this case, for my player, I'm setting it to negative 4.1. So basically my player cannot go higher or lower than 4.1. And we can also use that number for the ball as well. So the ball, when it gets past there, we know it got past our character, thus we lose a life. Okay, so I think that's pretty much everything we have to know about the player. We have the ability to get the input to move them. We can't move past the sides. We're locked into 0 on the Z, and we're also going to be locked into some point on the Y. Just to clear some things up, make sure the paddle is always the same position on the Y-axis. 0 on the Z, move paddle accordingly right up here along the X-axis. Great. So that's pretty much everything this script has to do. Now you really should take the time to go ahead and flush these out into actual real sentences. And I will off camera, but just to, like I said, keep things short. That's basically what we want to do. So I'm going to come down here and actually start making a few variables for all these things. And I'm going to start off with, well, Z-axis, and I'm actually going to make this static and public. And these will all be floats, as you can, as you've seen so far the way we're setting up. They can be decimal. So I'm going to call it Z axis position. And I'm actually just going to start this off at 0. Now the reason why I made this variable static is because I want somewhere in at least one of my scripts to have some value that I could set, so all of my game objects in my game are going to be set to the exact same position on the Z axis. Now normally I'd go ahead and throw this into a config file or some sort of game setting script where I'd make that script public and it would hold all the values for like all the different settings in my game. But since this is a very simple game, I'm just going to go ahead and throw it into one of my scripts, and since this is the first one I'm working on, it's going in this one. So, well, with that done, let's go ahead and look and see what we need next. So I'm just going to start at the top here. I need a way to get the player input, and to be honest, I'm actually going to be doing that down in the update. So I'm going to make the comment down here, get player input, move paddle accordingly along the X-axis. That will be down here too. Move paddle according to input along, I think it is one word, isn't it? Well, it is now. The X-axis. We're starting it off making sure it's equal to Z, and we actually want to have a position on Y as well. So I'm going to say public, and this one I'm not going to make static, as no other script should need to access this variable. And to be honest, because no others, well, I am going to leave it public though, just so we can edit it in the inspector. That's the only reason why I'm leaving this public, just for convenience. Normally I'd make it private. I really like to keep all my scripts really encapsulated. But since this is just a really quick tutorial, I'll leave it public just so we can access it in the inspector. Because you can always make it private a little bit later on. But anyway, public float, and this is for our Y position, so I'm just going to call it Y position. And I'm just going to start that off at, well, let's just start it off at 0. And I'm actually going to change the name up here. Instead of Z axis position, I'm just going to call it Z position. And of course, you can also shorten it just to be Z pos and Y pos. The next I want is my boundaries on the X axis. And again, these are floats. And I'm just going to call it X boundary. And I'm only going to take one value. And I'm going to start off at 0. Simply because there are two values, but the way we have it set up with it being in the center, the center of our game being the exact center of the screen, you're going to have a positive value and a negative value. So if we go ahead and take a look at one, now one's at negative 7.6, the other's at just regular 7.6. So all we need is one of the values, and just we can get the other value from that. So that's, I think, everything we need here. One thing I do want to add down here for one more line of code is check. I do actually want this on a new line. And I'm going to say boundaries. There we go. Basically check your boundaries before you move your player, because if, for they're already up against the side. Don't try to move them, even if the player is trying to move over that way. And that's pretty much it. You can actually tab these in because they are going to be if blocks. So this is the structure we're going to have. Roughly 3 commands. Since we set everything up here, I don't think I'm going to need the start function, so I'm going to go ahead and get rid of this. We'll save that off. And for input, let's go back into Unity. I'm going to go ahead and open up Edit, Project Settings, Input. And this opens up all our axes over here in the inspector. The one that I'm going to be using is one of the Unity default ones, and it's called the horizontal. And for those who've been following along with the tutorial series, they know exactly how this works and what all the values work. But a quick rundown of the values that we actually want to pay attention to here. The name is called horizontal, and that's how we're going to be referring to it. And they don't have anything in the description, which is fine. We don't need that. But pay attention to the negative button and the positive button. Every time we press either one of these buttons, and in this case it's the left arrow and the right arrow, we're either going to get a negative number or a positive number. So we just check that value, and if we're getting a negative number, that just means move to the left. And if we're getting a positive value, that means move to the right. And you'll notice below it has an alternate negative button and an alternate positive button. Basically, that just allows you to assign another set of buttons to this movement or this axis, to be able to capture the movement on this axis. So when they press A or left, it's the exact same thing. Same thing with right and D. And of course, you can adjust how much it moves. But Unity has some really good write-ups on what all these values mean. Go ahead and check them out. It's pretty simple. But what I really want to focus on really is just the name and these 4 little values. So I'm going to come back into our script. And after looking at those values, I realized there is one more public value I want to expose. And I'm actually going to put this right at the very bottom. And I'm going to make it a float. And I'm just going to call it speed. And I'll give it some arbitrary value. I have absolutely no idea how fast this is. But basically, it's how fast our paddle can move from side to side. It's a modifier. So that's pretty much it. So let's go back into Unity, select our actual player, which I'm actually going to call paddle now. And, well, let's keep it as player, just to make things a little easier for people following along. I do think paddle is a little bit more descriptive, but fine, we'll just leave it. So the Y position boundary, go ahead, it's the exact same one that we have up here. And now that I've actually thought about it, we do need the start method, because we're actually going to check to make sure that we're starting off at this position. But anyway, copy that in. And for our X boundary, I'm just going to go ahead and grab one of the walls, grab the value here, which isn't the exact value we need, but it's good enough to give us a good approximation. So I'll select the player. We'll paste this value back in. I'm just going to go ahead, save my scene, head back into MonoDevelop, and actually my start function is there. I did not delete it yet. So I'm going to start off there. So the first thing I'm going to do is make sure that I'm on the Z position and I'm on the Y position. So all I'm going to do is just simply move me there. And since I am going to be using the transform component of this game object quite a bit, I'm actually going to cache this. And this one I am going to make private because nothing needs to access this outside of the script. So private transform, and I'm just going to call it _T. And I always like to assign these in the awake. And of course, it helps if I type it all out right. So there we go, and I'm just simply going to say _T is equal to transform. Make sure it's the small t. And this way here, I now have a cached version of our actual transform component. We do this as an optimization, so we don't have to keep looking up the transform. We have a copy of it. Sure, it uses just a tad bit more memory, but we don't have to keep wasting processing cycles to get the transform. So now that we got it cached, I'm going to come down to my start method, and I'm going to go ahead and set the position to be, well, the position I want to be starting at. So underscore t dot position is going to be equal to a new vector 3, and the vector 3 we want to have an x, y, and a z component to it. And the x component is going to be 0, so we're starting off in the center of the screen. The y position is going to be the variable that we're actually using here. So y position. And the z position is going to be, well, the z position that we're using for the variable up top. And now this, when we start it up, should actually move our paddle to the center regardless of where it is. And we'll just do a really quick test on that. We'll go ahead and let's grab our player and move him over to the right over here. And we'll just go ahead and hit play. And as we see, it just puts us over there. Great, that works. So next, let's start working on the input. So let's head back into our scripts. And we got the awake method done. We have the start method done. I don't believe there's anything else we need for those. All we need now is, well, the update. So let's go ahead and start scripting that out. So we're going to use a simple if block here. We're just going to check to see if input dot get axis, and then we want the name of that axis, and we said that axis was called horizontal, I believe it was. No, horizontal. And we're just going to check to make sure that it does not equal 0. If it does not equal 0, that means the user is actually pressing it. And I'm just going to throw a debug statement in here to actually show what the value is coming out of that. So let's put a space there, and I'm actually just going to grab this line and right up to there, just paste it in. So at this point, I don't care what the value is. I only care that they're actually pressing something. So let's go ahead. We'll start this up. And as you can see in the console, it's going to be a number between -1 and +1, depending on which way you push. So let's take this little bit of data that we just gathered here and figure out exactly what we want to do. So I'm going to go ahead and delete this. I'm actually going to get rid of the curly braces too. And we have check boundaries and move paddle. Now there's a lot of ways to actually work this logic, and I've already decided to change my mind. So we'll just go ahead and actually do the move part first, and then we'll check bounds. So actually I am going to need curly braces here because it's the way I'm going to be doing it now. So let's go ahead and move the player. So that's _.transform, or sorry, _t, which is our cached version of our transform. And I want to grab the position. I'm going to assign it a new vector 3. And just like before, that vector 3 needs an x, y, and a z. And the y position we already know is y pos. And the z position we know as z position, sorry, not pos. But the x position, now this is where we actually want to move our character. So we're going to actually take our current position, which is _.t.position.x. Let me retype that. Position.x. And I want to apply some value to it. And that value I apply is going to be made up of 3 parts. I'm going to actually use the value that I'm getting from here. So for instance, when I'm pushing to the left, it starts off at 0 and ramps up to -1. And as I go to the right, it starts off at 0 and goes to 1. And it takes a couple frames before it actually gets to that -1 + 1. So by grabbing the actual value that I'm actually getting from this axis, it will give me a little bit of kind of an acceleration to my movement. Now, if you don't want this acceleration, instead of actually just getting the input, you can just use +1 or -1. But I want to at least try it with that slight acceleration. So I'm going to take that. I'm going to multiply it by that speed that we've set. And then I'm also going to multiply by time.delta time, which will even my movement out according to my frame rate. And let me see, that should be about it. Let's go back in and we're going to try this out. There's no errors. So of course, it starts us off in the center. And as we move left and right, now it's too slow. We don't have any balance checking, so we can go through. But you see how we kind of have a little bit of an acceleration when we switch from side to side. It's not a lot, and we can actually go into the input manager and change how much acceleration we get from that axis. But that's fine, actually. I don't like my max speed, so I might want to start ramping that up. So I'm going to try with 10. We'll click back in. That's better. I'd like to go a little bit faster. Let's try 20. Now I do have my game running, so that means these values will not be saved. I think that's a little too fast. So let's try 15. That seems like a good speed. So it's about 2 seconds to go from one side to the other. I like that value. So I'm actually just going to stop the game, come into my speed, and set it to 15 for default. So that's good. Let me just start it back up real quick. And well, next I want to make sure I have some bounds checking in there so I can't go through these walls. And I do have my boundary set up, at least a value for it, and it is the positive value, so I want to take note of that. And I'm going to go down to this check balance part. Now I'm just going to say if, and I'm actually just going to check my position. So t.position.x, if it's less than, we'll say negative x boundary, and then we want to actually move us to the x boundary. So we'll say, well, we're just going to copy this whole line up here. I'll paste it in. And we don't want all of this. What we actually want in there is just negative x boundary. And I'm going to take this whole line again, or both those lines, and duplicate them. Except now I'm going to use an else if. And I'm going to check to see if my position on the x-axis is actually greater than the positive value. So that if it's positive, or if it's greater than that value, move us back. So we'll save that off. Quick check, everything looks okay. I'm going to come back in, start it up. Now I'm still going to go through because of the length of our bar, but it actually does stop us. And as I'm pushing to the right, I can't go through it any further. And of course, I can start going to the left and it stops us. Now we actually want to stop a little bit early, and this is going to be dependent on the actual width of your actual bar. So let's take that into account for our movement. So we'll stop it. We'll head back into our script here. And the way I want to work this is I want to be able to take half the width or half the length of our bar, and also half the width of our wall. So actually maybe it might be easier to look at it. So I want to take half the width of our bar here, or the length. I guess it really depends on how you look at it, but I want to take half of it. I want to subtract that from the edges. Plus, I also want to take half the width of these bars as well, these walls, and subtract that as well. Now, I already know these walls are 1. If I go ahead and look at them here, on the X they're a 1, and my bar is 2. So I can go in and just say, oh, we'll add to this one, because you want to add to the negative numbers and subtract from the positive numbers. But if we add on our underscore t dot local scale divided by 2, and of course you could just use 1 here since we already know that value. And I actually think I am going to do that. Either or, this here just cuts down on the actual have to do the calculation. And to that, we're also going to add half the width of our wall. Now, since we don't actually have access to a wall, this is where having that static game setting script would really come in handy, because we can just put the value in there. I'm just going to actually hard cast the number in. It would be like this here. And since we actually know both these values, I'm actually just going to go ahead and add them together automatically in my head, which isn't really that hard. But you get the idea of how I'm arriving at that number. Now I'm also going to want to take this and add it down here. And then on this one here, we actually want to take it away. And I'm actually just going to copy it and paste it in down here. So let's go see how that worked out. I'm going to go ahead, start it back up. And now when we move over, we notice we stop here right at the edge where we're supposed to. And of course we zip over there and it stops automatically. Now I did actually hard cast the numbers in 1.5, but I just want to quickly go over and make sure you understand how I got these numbers. Half the width of my bar, which is, has a scale of 2 because the base unit was 1. If you're using your own assets, try to stick to Unity's base scale of 1 unit, and you should have no problem with it. And since I'm multiplying it by 2 on the X, it's 2 divided by 2 is 1. And the width of my walls is 1, and divided by 2 is 1/2. So add them together, you get 1/2. But that's pretty much it for our player class. I just quickly want to look at it one more time. I don't see anything else that we're actually going to need, and if I do find something a little bit later on, we can come back and add it. That's it really. So let's go on and move on to our next class.